All right, ladies and gentlemen, welcome to this recording of the Test 2.2 review solutions. And we are going to begin with number 1, where we're asked to sketch the solution. So we're not evaluating a point, we're drawing. This is a drawing problem. So I'm going to choose two colors, blue and red. And so the top equation will be blue, the bottom equation will be red. And on the top equation, I need to identify what the inequality symbol means, less than or equal to. A little refresher, that means I'm going to have a solid line, a filled in dot, shaded below. And then down here, I've got a less than or equal to. And just a quick little refresher, that means I'm going to have a solid line, shaded in dot, shaded below. Okay? There's some other things I need to know. I know that my slope, m, is negative 5 over 3. Okay? I know that my y-intercept b is negative 3. Down here, I know that my slope m is negative 1 over 3. And I know that my y-intercept is 1. Okay? So with those two pieces of information, I can draw the line. We'll start with the blue line. I put my first point at negative 3, and it's a filled-in dot. Okay? And it tells us to fall 5 and then run right 3. But if you notice, we can't fall 5. We'd run off the page. So we have to reverse. We have to rise 5 and then run 3 to the left. Do you all understand why and how we do that? When you can't fall 5 and run 3 to the right, you just reverse. You go up 5 and 3 to the left. It's the same thing. This is a filled-in dot. So we're drawing a straight filled-in line. We put arrowheads on the end. And then we shade below. I like to think of this as airplane wings. Okay? Everybody look at me real quick. Everybody knows what, this is T-pose, right? Everybody knows what below is here. But the airplane banks here, below is this way. So I just remember that being a question in my own mind, like, when it's real steep like that, the concept of below becomes a little bit ambiguous, but that's below. Okay? All right, that's the blue line. Now onto the red line. Solid, filled-in dot. This is a fall of 1 and a run of 3. We're going to be able to plot this one just normally. So we put a filled-in dot at the y-intercept of 1, and then we go down 1 over 3. Okay? That's all we need is 2 points. It's like they say about country music, you need 3 chords and a guitar. For a line, you just need 2 points. And I guess you need a slope and a, well, you just need 2 points. And now shade below. Okay, that's good. Remember to include the line in your shading. Even if it bleeds over a little bit, that's fine. You want to make sure the reader knows that you know that even points on the line are part of the solution. So the double shaded region, I'll focus in on a different color and kind of identify. This is the double shaded region. You want to really somehow identify that. Right? This is your double shaded region right here. Okay. And that is number 1. And here we are on number 2. Thankfully, we can just graph. Okay. These lines, again, I'll choose blue and red. And this symbol, this symbol here is a less than or equal to. That's a solid line, filled in dot, shading below. This symbol here is a greater than or equal to. solid line, filled in dot, shading above. Okay? Let's do our slopes. M equals 5/3. And look, M equals 5/3. What do we know about these two lines just based on the fact that the slopes are the same? Parallel lines. Okay, we should be expecting that. Okay, and then how about y-intercept? What's the y-intercept of the blue line? So crosses the y-intercept or the y-axis at 3. Where does the red line cross the y-axis? At 2, right? All right, so here's what you're going to draw. Blue line, 2, 3, right here. And then it says go up 5 over 3. Well, we can't do that, so let's go down 5, okay, over 3 to the left. There's point 1, right? You can't go up 5, but you can go down 5 and then go 3 to the left. So break out that ruler. Solid line. Arrowheads, shading below. Airplane banking this way, shade down. Okay. And now red line. So red line, same slope, so it's going to be parallel. I won't have to change the ruler, right? But I'm starting at 2. So all we're doing, this one's real simple. I mean, now we still can't go up 5, right? But we can go down 5, and then over 3. 1, 2, 3. And it's going to form a parallel line. You just like this. And it's shaded above. Well, this is weird. So I had a student in another class. They drew the lines wrong. They had the they were going down instead of, but they got the idea that the shaded region is actually this region in the middle, right here. That's the solution region. That's a weird one, right? It's a weird problem. Okay, and that's the end of number 2. All right, here we are on number 3. Unfortunately, we're given the equations in standard form, ax plus by and c, and so we have to get from standard to slope intercept form. So we're going to subtract ax from both sides and then divide by b, right? So let's take the first example. If we multiply or divide by a negative number, we flip the inequality symbol. So I always like to put ones in front of what I call naked variables. It makes life much easier. So just put a bunch of ones for me. Okay. Now we're going to work with equation 1. We'll switch up our colors here. I'll do green for the top one. And a good contrast would be this kind of yellow color for the bottom one. Now, let's take a look at the green. So over here, we're going to look at the green. 2x minus 1y greater than or equal to 1. Okay? You ready for the algebra? Let's just go ahead and peel that Band-Aid off. Minus 2, I said subtract ax from both sides, so minus 2x on both sides. And you have negative 1y greater than or equal to. Always lead with the variable. Negative 2x, and then this is a positive 1 plus 1. That confuses a lot of students, so I wanted to make sure to mention it. Now we need to divide everything, or each thing, by -1. In other words, by the coefficient of the y variable, or in normal human language, the thing in front of the y, the number. Okay, so that leaves y by itself. And did we divide by a negative? So we got to flip that sign to be this. Okay, and this becomes 2x minus 1. Okay, so that's my green. Okay, that's my green. Okay, now let's go ahead and plot the green. So we take a little break from the math. It's a less than or equal to symbol, so less than or equal to means solid line, filled in dots, shaded below. Okay, so what's my y-intercept here? -1. What's my slope? Up 2 over 1, right? Like that? Does that look right? Yeah. Okay, draw a line in. Zoom out here. Okay. And I'm shading below, right? Airplane wings shade this way. So let's get a light green color going, and let's get it big. Do I get close to the line, or do I touch the line with my shading? Touch it, yeah. In fact, you know, if it spills over a little bit like that, that's okay. Like, you just want to really indicate to the viewer that you understand that it's on the line. Okay, now the second one, the red equation. Okay. Let's separate our work. And let's do the red equation. We have 1x plus 1y is greater than 2. Now right off the bat, can anybody tell me for sure, am I going to flip this symbol or no? No, I'm not. Okay, remember, ax plus by equals c. We subtract ax from both sides and divide by b. All right, so we're going to subtract 1x from both sides. It's more like the less you think about it, the easier it is. 1y is greater than -1x plus 2. And then divide by 1. That's not going to have any effect at all. So y is greater than -1 over 1. I write it like this so rise over run is obvious, plus 2. So what's my y-intercept? 2. Now, let's talk about the inequality symbol. This is a greater than symbol. That's a dashed line, open circles, shading is above. So I go to 2 on the y-axis, put an open circle. Now, what's my slope? Down 1 over 1. Okay, so it's a 45-degree angle. So you just can do this. Right? That's what's happening. So let's bring in the... Let's get it at 45 degrees. Okay. Dash line or solid line? Mm-hmm. Got some people here who are going to do really well in this exam. Okay. And I'm shading above, so... Do I touch the line with this highlighter? No. Okay. There you go. There's your double shaded region is right here. It's this region here. Okay. The purple region. All right, that's the end of number 3. All right, here we are with number 4. So remember, first things first, find any variables without numbers in front of them and go ahead and put the ones. These are in standard form. Ax plus by equals c. subtract ax from both sides, divide everything by b. That's the simple formula to get it into slope-intercept form. So let's make this our green equation, and I'll make this an orange equation here, okay? So, green equation first. I have 1x plus 2y is less than -2. Quick question, am I going to flip the sign? No. So we can go ahead and analyze that. That's a less than symbol, dashed lines, open circle, shading below. All right, so you're already, if you had a multiple choice, you would know. So now, remember, subtract ax from both sides and divide by b. So subtract 1x from both sides and divide by 2. Okay. Got 2y less than -1x minus 2. Divide both sides by 2. Okay. I have y is less than -1 over 2x minus 1. -2 over 2 reduces to -1. So my y-intercept is at -1. It's an open circle. And then I go down 1 over 2, down 1 over 2, etc. We can graph that in very easily. Dash line. Okay, arrowheads, please remember your arrowheads. And I'm shading below. Don't touch the line. So leave an air gap there. Okay, and now let's do the second one. So we're given 5x plus 2y is greater than or equal to 6. Am I going to flip the sign? No. So quick analysis. Greater than or equal to, that's going to be a solid line, filled in dot, shading is above, okay? So remember, ax plus by equals c, subtract ax from both sides and divide by b, so subtract 5x from both sides and divide by 2, right? That's our plan of action. So 2y greater than or equal to -5x plus 6, divide everything by 2, divide by 2, divide by 2, cancel, cancel. Y is greater than or equal to -5 over 2 plus 3. 6 divided by 2 is 3. My y-intercept is at 3. It's a filled in dot. Now I go down 5 over 2. Filled in dot. Okay? So I filled in a dot that was previously unfilled, making it defined at that point. Solid line. There we go. Shading is above. And I touch the line this time. Maybe even bleed over the line a little bit. It's okay. So the double shaded region is this area right here. Just want to really make this clear. It's this region right here is the double shaded region. Okay? So if it asked you, is this coordinate in the solution, you would want to check that area. All right, and that is the end of number 4. All right, here we are with number 5. So in this problem, we're asked to solve using substitution, not elimination, and not a calculator. So in order to do that, I have to first get one of these equations with y by itself, and the easiest equation is going to be the top one. I mean, I could get either variable by itself, but what we're going to do is get y. Okay, get this into y equals form. So we take -2x plus 1y equals 8. Okay. Now, you're always trying to cancel things out to get them to move over. So we're going to first add 2x to both sides. Nothing changed here. It's ax plus by equals c. So minus ax on both sides, divide by b, right? But in this case, since a is negative, it's plus ax on both sides. So, okay, that cancels. So now I've got y by itself equals 2x plus 8. And it's this that I'm going to substitute. So this 2x plus 8 right here, I'm going to stick this 2x plus 8 right here. Okay, you can't use the first equation because then you're doing just a loop. All right, so plug in 2x plus 8 right there. Does everybody understand what I am telling you to do? That's substitution. Okay, so let's go ahead and do it. Okay, so now we're going to go ahead and perform that substitution. So we write 3x minus 2, open parentheses, 2x plus 8, close parentheses, equals negative 11. Okay? And now we've got to remember, this negative 2 must be distributed as a negative 2. The most common mistake that we see as math teachers is students forgetting to include that negative symbol right there, okay, in the distribution. So now we have 3x minus 4x minus 16 equals negative 11. Add 16 to both sides. Cancel here. These are common terms, so that's negative 1x equals 5. Now we divide both sides by the negative 1, and we arrive at the conclusion that x equals negative 5. Okay, that's very important. Now we know one of our variables, so we can just take that and plug it into either equation. It looks like the top equation is just easier to work with, so we'll go ahead and substitute into the top equation. So what I'm going to do is just write negative 2, open parentheses, negative 5, close parentheses, plus y equals 8. Well, that's 10 plus y equals 8. Now I subtract 10 from both sides, and I get y equals negative 2. Therefore, okay, this means therefore, right? Therefore, the solution is, open parentheses, x comma y, and that would be negative 5 comma negative 2. No easy way around that, folks. That's substitution, okay? And that is the end of number 5. All right, here we are on number 6, and we're trying to substitute again. This time I want to do the x variable, because if I use the top equation, it would be fairly simple to isolate the x variable by just subtracting 3y from both sides. Okay, so we can actually just kind of make an arrow like that and say x plus 3y equals 10. All right, and then subtract x from both sides. And we all know that this is 1x and we have 3y equals negative 1x plus 10. Putting that 1 there, a negative 1 becomes important right now. Okay? Because now you see the fraction. A lot of students don't see the fraction. So you have y equals negative 1/3 x plus 10/3. And when I see a problem like this, okay, I think ahead. And I look over here, right? I see that 3y. I'm going to be substituting this in here, all right? So I'm going to write this like this. Y equals negative 1x plus 10 all over 3. Okay? Does everyone understand that that's possible? Does everyone understand that these two statements are identical to one another? Okay, as long as you understand. This is the preferable substitution. Okay? This isn't a math trick, or I'm not pulling anything. I'm just telling you, this is going to allow the 3's to cancel. That's what's going to happen, okay? That's why I'm thinking ahead. So now we're going to substitute that into the second equation. And so we're going to do that here. 5x minus 3, big open parentheses, negative 1x plus 10 over 3 equals negative 4. And now here comes that beautiful thing. The 3's cancel. Okay? Now that leaves behind a negative 1. Please don't forget that. So now we write 5x, and I'm going to go ahead and show this intermediate step. Open parentheses, negative 1x plus 10 equals negative 4. So now I distribute this negative 1, which is just another way of saying change all the signs inside. And I got 5x plus 1x minus 10 equals negative 4. Add 10 to both sides. Combine these like terms. And we get 6x equals 6. Divide both sides by 6. X equals 1. Okay? Now that you know that x equals 1, I would suggest plugging it into the top equation. Right? 1 here. It's going to make life a lot easier for you. So let's go ahead and do that. We're just going to write 1 plus 3y equals 10. Subtract 1 from both sides. You can see where this is going. 3y equals 9. Divide both sides by 3. Y equals 3. Okay, so we got both our x and our y. So our solution, x comma y, is 1 comma 3. Okay? And that is the end of number 6. All right, here we are on number 7. Now, they're asking us to solve using elimination. Okay, so this is way easier than substitution. We just have to multiply the top or bottom by some number that will make it possible for us to delete one of the letters. So you've got two options. You can either multiply the bottom number by 7, thus eliminating the x variable, or you can multiply the top number by 2, thus eliminating the y variable. Now I can just tell you, multiplying 7 times 18 and by negative 19 is going to be a lot of math that we don't know. But we can do the 2 on the top, we can do it all in our heads. So why don't we multiply the top equation by positive 2? Okay? right? This is called a scalar. And it scales it up, and this distributes to every term. Okay? This is elimination by addition. So what we're going to show the result of that here. All right? So 2 times negative 7x is negative 14x. 2 times negative 9y is negative 18y. Equals 2 times 16 is 32. Now just write the second equation directly beneath it. It's 1x plus 18y equals negative 19. And now if you think of this as a math problem, an addition problem, okay, and you add, you can just cancel these. Okay, that's what elimination means. We just eliminated. So now let's perform the rest of the math. So negative 14x plus 1x is negative 13x. And then this is a subtraction problem. You can't take 9 from 2. So, sorry, you have to borrow. And then 12 minus 9 is 3. 2 minus 1 is 1. So negative 13x equals 13. We divide by negative 13 on both sides. X equals negative 1. So now we already have one of our variables. It's much faster. And look, we can plug it right in there, can't we? Be super easy. So now we have negative 1 plus 18y equals negative 19. Well, how about we add 1 to both sides? And guess what we get? 18y equals negative 18. Divide both sides by 18. Y equals negative 1. So the solution is negative 1, comma, negative 1. That's the end of number 7.